Hi everyone, hi, welcome to another episode of the channel. So today teacher is going to guide on chapter 2 differentiation. So of course, if you're watching this during the premiere session, don't forget to like, don't forget to even you can chat in the live chat session so that I know that you are watching and trying all the questions together with me. And in today's chapter, okay, differentiation, most of you have actually started this chapter in your school, and most of you are struggling, so that's why teacher actually decided to do chapter 2 first. Okay, but I'll still upload all the formative exercises, questions, okay, as time goes, because number one, teacher want really the students to understand step by step how to do the answers, and not just because you are supposed to do the questions as homework and then you copy the answers. Okay, no. So I really want all the students to really understand what you are learning. So for this chapter, okay, differentiation, why do you actually learn differentiation? Have you ever thought why? What is the differentiation actually about? And you are learning this in form 5, okay, which if you follow the KSSM syllabus, this was in form 4. Okay, so let me actually draw this. I think most of you are familiar with this U-shaped graph, the smiling graph. Okay, if let's say now we have a graph, okay, a smiling graph. This is X, this is Y. Okay, and let's say now I draw a straight line passing through this U-shaped graph. Okay, when a straight line passes through this point, what does it mean? Okay, here we can actually find the, okay, this is called like the tangent line. Okay, so we will find the gradient over here, right? We'll find the gradient. So finding the gradient, okay, over here is what differentiation is all about. Okay, differentiation, or we call first derivative. Now where do we apply this in real life? There's a lot of things. For example, like a profit or loss for a business, or even like engineers doing buildings. Okay, they want to know how much exactly at this part of the building structure they need, let's say they need cement, or anything. So now let's see how we differentiate. Okay, because teacher is going to guide based on the simple steps. Okay, everything is going to be based on simple steps. So if you have your A4 paper or you have your notebook together, let's do together with teacher, because what I realized is most students still couldn't grasp the textbook method, because textbook has explained in very much in detail. Actually, it's a very good thing for you to read, but I have simplified it. Okay, so basically teacher has already done the form 5 notes for all my form 5 students, okay, my classes. So this one, teacher is giving this as a tip for you, okay, if you are not from my class. Okay, so let's say we want to find the limit of a function. So a limit of function usually happens at this axis, okay, the x-axis. So let's say if the x is approaching 2, what is the limit for the function? That means we want to find what is the value of the fx. So usually the y here will be the fx. Okay, so just look through the steps first. Okay, I read through. Okay, substitute x equals to 8 directly into the function. Okay, second, if 0 over 0 or infinity over infinity is found in the solution, then the function have to be simplified by factorization. Okay, third one, if a is not equals to 0, that means a is a number. Okay, let's say this is number over 0, then it's infinity. If it's 0 over a number, then it's 0. Okay, what is this, teacher? I don't really understand. Okay, now what I mean here is, okay, the first step, okay, when you want to find the limit, okay, of a function, because the first part of differentiation is you need to find the limit. Okay, what you do, usually they'll give you the limit like this. Okay, limit x approaching to 1. So the first step is you can directly substitute this one inside the function. Okay, which means inside here 1, 1, and 1. But let's say after you substitute, you get 0 over 0, or you get infinity over infinity. If you get like this, these answers are not acceptable. Okay, so what you need to do is you need to simplify this function, or you need to factorize it. Okay, so usually this is a tip, you can write this down. Usually if you have a quadratic, okay, you have a quadratic, or even if you have power of 3, always factorize the equation, the function. So the third one, if a is not 0, that means if let's say you get, after you put in and you find the value, you get 6 over 0. Let's say you get 6 over 0, you key in calculator, what do you get? Let's just try 6 divided 0. You get math error. So what does math error mean? You cannot define. So we write that as infinity. But if let's say you get 0 over a, that means 0, let's say 0 over 6. So 0 divided 6 is 0. So the answer is, so this is what you need to know. These are like the tips before you actually able to answer. Okay, so now let's look at how to evaluate. Okay, let's look at example 1. Okay, limit of x approaching 1, x square plus x minus 2 over x square minus 2x plus 1. Okay, I'm going to just do this part first. Okay, I'm going to substitute the value. Okay, let's say now we are substituting 1 inside this entire function here. Okay, so it's going to be, okay, limit x approaching 1 means this is going to be 1 square plus 1 minus 2 over 1 square minus 2 plus 1. Alright, let's see what's the answer. 1 plus 1 is 2, 2 minus 2 is 0. 1 minus 2 is minus 1, minus 1 plus 1 is 0. 0 over 0. Can this answer be accepted? Cannot, because based on our rule, 0 over 0 or infinity over infinity, you must simplify the solution. So that means what you need to do is you need to simplify this. Okay, so use factorization. Okay, this one, x square plus x minus 2, you can use your calculator. Okay, you press mode 4 times. Okay, then you press degree. Press mode. Okay, press mode 3 times, press equation, EQN, then move to the right side and press degree 2. Okay, now we are going to apply this. So A's value is 1, B is 1, C is negative 2. So X is 1 and negative 2. Okay, so this is going to be like this, X minus 1 and X plus 2. Okay, so factorize this. And then for the down one, how to factorize? As you can see, you can also key in your calculator 1, negative 2 and 1. So we get only one answer. What does it mean by only one answer? That means the roots are repeated roots. Okay, so it's going to be x minus 1 and x minus 1. Okay, so now this is the function that we must use. So when you write your limit, it's going to be like this now, x minus 1, x plus 2 over x minus 1, x minus 1. Okay, so this is what we must do. Now, as you can see here, okay, x minus 1 and x minus 1, okay, can cut off. So what we are left with? We are left with limit of, okay, x approaching 1, we are left with x plus 2 and x minus 1. So now you substitute and see. So 1 plus 2 over, this one will be 1 minus 1. So you will get 3 over 0. So 3 over 0, look at our rule here. If you have a number on top and you have 0 below, what does it mean? This is infinity. So that means the answer for this will be infinity. Okay, now let's look at this one. Okay, this one looks a little bit different because if you realize here, there is a square root. Okay, or I can also say that as cert x plus 1. So when you have a cert, okay, what you need to do is you need to multiply with the conjugate. Okay, we multiply with the conjugate. Okay, because if you put 0 in, okay, you'll get 1 minus 1 over 0. So that's not going to work. So what we're going to do is we're going to multiply with the conjugate. Okay, the conjugate is going to be square root of x plus 1 plus 1. Okay, so this part changes. Here, this part change. Here, the inside one remains. Okay, so this is the conjugate. So now let's times up and down both. So limit of x towards approaching 0. Okay, square root of x plus 1 over x minus 1, okay, times square root of x plus 1 over square root of x plus 1 plus 1. Okay, so now you times, you will get over here. So by now your form 4, the cert should have been, you should have actually mastered. So when cert and cert times, the cert will go off, okay, no longer there. So the answer will be x plus 1. Then plus cert x plus 1 minus cert x plus 1 minus 1. Usually teacher won't write this, okay, because whenever you times the conjugate, you just take the front and front, you times, then you take the back and back, okay, because the middle will cancel off. So teacher usually won't write, but since I'm explaining this to you, so I'm writing this, okay. So over here, this is going to be x square root of x plus 1 plus 1, okay, right, like this. Now what are we left with? Final part here. Okay, let's look here. Cut off already, here plus and here minus, so we only left with x on top, right? So up got x divided by x square root of x plus 1 plus 1. So the x and x also cut off already now, okay. So the final function that I think we can write here will be 1 over square root x plus 1 plus 1. Okay, so now we substitute the value of 0. We will get 1 over 0 plus 1 plus 1. So here we will get 1 over 2. So the answer, the limit when the limit approaches x to 0, we get the fx value as 1 over 2. Okay, so I hope you understand this part. So this is how you solve. When you have square or you have a cert, you times conjugate, this one you factorize. Okay, now let's look at first derivative. Next example. Okay, for the next example, this one, if let's say you have your textbook with you, your textbook also will give this, okay, as your formula. What you can do is, okay, for now teacher is going to, as I said, I'm teaching just the steps, okay, so the steps are easy for you to follow. Now first derivative means, that means you're finding differentiation. Okay, so when you're finding differentiation, they want to use first principles. Okay, what are first principles? First principles are where you use the formula to actually obtain the differentiation, meaning the gradient. Okay, if you look at your textbook, you can look at page 35. Okay, this part. Okay, read through this part to understand actually how you get the differentiation. But okay, just take note that you need to understand the symbols first. Okay, so actually this was the guy, I think you know him, Isaac Newton. Okay, so he introduced the concept of limit, and this is actually the basic of calculus. Okay, calculus. So if you plan to go to university, take maths, you will learn calculus, and you know it will be fun, definitely. Okay, let me go through for this. Okay, first you can see here there's a different symbol here, dx, like that, and then you have dy. It's kind of like curvy. What does this call? This is called delta x. This is called delta y. Okay, delta means small changes. Okay, small changes. Now what do they mean by the small changes? Well, let's say okay, we go back to this, now the graph I draw. Remember here the graph. Okay, what if your tangent line was over here like this? Or maybe your tangent line was like this, or maybe a little bit like this. Okay, can you see that there's different positions to draw the tangent line? So here to here, here to here, here to here, all right, there are some small changes happening, right? So this is called delta x, the small changes happening. So now look at this. Okay, so that is delta x, okay, that's delta x. So the small changes that are happening, and now we want to find the first derivative using the small changes. Okay, so first step, find your delta y first. Okay, by using this, if you can memorize this. Okay, memorize this. Delta y equals to f x plus delta x minus fx. Okay, now I'm going to do step 1 first. Okay, step 1, find delta y first. So let's find delta y. Okay, so now I'm going to apply delta y first. Okay, first step. Okay, always if can, this is teacher's suggestion, you write down the formula every time, because if like you are now starting, you are learning this chapter until at least March or April. Okay, keep writing formulas, because that's one way for you to train to memorize. Okay, so now first of all, I'm going to let y equals to fx, because I'm going to change this as function. Okay, this is going to be my function. So that means my fx is equals to 3x. Okay, my fx is the one equal to 3x. Okay, so now let's do the first step. Find delta y. Okay, so first step, we write the delta y. Okay, first of all, you know why I changed this to fx? Because we are dealing with fx. See, function fx. So I don't want this to be y, so we just change it to fx. Okay, so delta y, okay, copy down the formula x plus dx minus fx. Okay, done. Okay, now we substitute the fx. So it's going to be like this. See carefully. Delta y equals to, okay, fx is 3x. If fx plus dx, what will happen inside here? This will be substituted inside here, isn't it? So it's going to be 3x plus delta x. Okay? Okay, yeah? Okay, then minus fx. What is fx? Fx is 3x. Alright? Okay, it's actually simple. Okay. Then write back delta y equals to times in. So 3x plus 3 delta x. Okay, remember this delta x is together. Don't separate the x outside and write like this. Some students wrote like this. Cannot. The delta x is together, so don't write that way. Okay, so then minus 3x. Okay, anything that we can solve here? Yes, 3x minus 3x, done. That is gone. So we are left with 3 delta x. Okay, first step done. First step done. Now let's obtain the ratio. Obtain the ratio means, okay, for the second step I use different color. That means you must divide both sides with delta x. Okay, this means divide both sides, okay, with delta x. Bahagi. Okay, so please, if you can just write this down. This step, there's only 3 steps actually for you to do this first derivative, and usually in exam will come out, and I don't want you guys to lose your marks if you don't, you suddenly missed out any of the steps. So now let's do the second one. Divide both sides. So divide by delta x, divide by delta x. Here cut off. So our delta y delta x ratio obtained or not? Yes, we got 3. Okay, now we already got 3. What is the last step? The last step is find the limit. So find the limit. This is where we find this. Okay, limit of this. So we put a border here. Okay, so now we are going to do dy dx. That means this is actually the first derivative. Okay, but we are working from the back like that. Okay, now this part done. Okay, now we are doing this. So limit of delta x approaching 0 of delta y delta x. Write this first. Write this part first. Okay, write this part first. Okay, then you write down what is delta y delta x. This now we got 3. So now you write down 3. Okay, got any delta x here or not? Don't have, right? So this delta x, there's nothing for us to substitute. So since there's nothing for you to substitute, so the final answer is 3. Okay, so that means our final answer dy dx is equals to 3. Okay, so it's equals to 3 because this is what we are actually finding, but we worked from the back behind, find then the limit, and this is the dy dx. First step, second step, third step, already found. Okay, now what you guys do, okay, copy this down in your book because you guys need to practice. Okay, try this first. Okay, let teacher give you I think I give you about 2 minutes. Okay, try this first. Okay, I'm really going to pause the video, or I'm just going to let the video go on for 2 minutes. Try, and then I'm going to do the answer for you guys. Okay, I hope you guys are like halfway through. Okay, I'm just going to get started. Let's check whether your answer is the same as teacher. Okay, first step, write down your let y equals to fx. So this is going to be our fx. Then so that means our fx is 5 minus 2x. Okay, then find delta y. So write down the formula of delta y. Delta y is x plus delta x minus fx. Okay, now we can substitute. This one got minus, right? So what is fx actually here? fx is the whole thing. Okay, so what we can do is we can actually write the 5 first minus 2x plus delta x, like that. Okay, then minus 5 minus 2x. Okay, this one I put a different bracket here. Okay, now so our delta y will be 5 minus 2x minus 2 delta x minus 5 plus 2x. Okay, let's try to solve. Which one can solve? So 5 minus 5, no more. Negative 2x plus 2x, no more. So we are left with negative 2 delta x. Okay, first step done. Alright, now I hope you guys got until here. Yeah, moving on to the second step, which is divide both sides by delta x. Okay, divide both sides because I want the ratio. So here cut off. So delta y delta x is negative 2. Okay, now the third step will be find the limit of delta x approaching 0. Okay, delta x approaching 0 for delta y delta x. Okay, so the limit of delta x approaching 0 for negative 2. Okay, is negative 2 got any delta x here for us to substitute the 0? Don't have. So the final answer is negative 2. So that means our dy dx, the first derivative, okay, is negative 2. Okay, done. So I hope you guys got the same answer. Okay, now I'm going to go into formative exercise 2.1, page 37. Okay, so what you guys do, I'm going to stop the video until here, and you guys can click on the link below or just search for the second part. Okay, formative exercise 2.1, and I'll show you all the answers step by step. Okay guys, see you in the next video.